My dear students, a very good morning to all of you. As you can see, I have drawn two diagrams. One, that PQR is a triangle and XY is a line passing through P. And the next is that PQR is a triangle and QR extended to S, and then RX is another line. Now, in these, there are two theorems, two important theorems. That sum of measures of three angles of a triangle is equal to 180 degree. And number two is sum of measures of two remote triangles equal to measure of exterior angle. Equal to measure of exterior angle. Now, why I have drawn these two diagrams side by side? Just trying to show you that this one, by this one also, you can prove both the theorem, and this one also you can prove both the theorem. How? You see one. See, this is, suppose this is 1, this is 2, this is 3, this is 4, this is 5. And here also, this is 1, this is 1, 1, 1, 1, 2, then 3, and then 4. And then suppose this one is your 5. Okay. Now how? You see, first of all, that XY is drawn parallel to QR and PQ is a transversal. If two lines are parallel and a transversal, then the angle opposite to the opposite side of the transversal are alternate angles, and alternate angles are equal. So angle 1 equal to angle 4. Similarly, angle 3 equal to angle 5. Angle 1 equal to angle 4. Angle 1 equal to angle 4. Angle 3 equal to angle 5. Then if we add 1 plus 3 equal to angle 4 plus angle 5. Then what is that? Angle 4 plus angle 5 equal to angle 1 plus angle 3. So that means sum of measures of two remote triangles equal to measure of two exterior angles. These are the exterior angles. And now if you add 2 to both sides, then what we will get? We will get all the three angles of the triangle and all the angles of the straight line. And then as a whole, angle 2 plus angle 4 plus angle 5 equal to 180 degree. Then see, now here also same. Here little bit different than this one. Here actually one side, particular one side. Here not particular one side. It is a separate line drawn parallel to QR. Here actually QR extended to S in such a way that PRS is an external angle or exterior angle. Then we have drawn RX from R in such a way that RX is parallel to PQ. RX is parallel to PQ. Then PQ parallel to RX and PR is a transversal. That means angle 1 equal to angle 2. Why? Alternate angles. Again, angle PQ parallel to XR. Then QS is a transversal. Then what will happen? Angle 3 equal to angle 4. Then you see, if you add just like this one, if you add angle 1 plus angle 3 equal to angle 2 plus angle 4. That means sum of measures of two remote triangles equal to measure of exterior. Now once again like this one, we have added 2 to both sides. Here we will add 5 to both sides. Then what will happen? Angle 1 plus angle 3 plus angle 5 equal to angle 5 plus angle 2 plus angle 4. The angle 5 plus angle 2 plus angle 4 equal to how much? It is a straight angle. So ultimately angle 1 plus angle 3 plus angle 5 equal to 180. So that's the reason. So any one diagram we can show through both the theorem. Now today in this class we will use the application of these angles. That sum of measures of three angles of a triangle is 180 degree, and sum of measures of two remote triangle equal to measure of exterior angle. Okay, so let's see. Start with exercise 6.3. Exercise 6.3. See, our diagram is already given. Which is the diagram? Diagram is 6.39. So first of all, I will draw the diagram. This is the diagram. What is that? S, P, R, Q, T, 0 degree, 35 degree, and then remaining. Okay. Now here, what they are asking, you have to find out PRQ. PRQ. This one you have to find it out. Now here we can do two ways. How? First you take out this angle by using linear pair. And then sum of these plus these equal to this one. Sum of measures of two remote triangle equal to measure of exterior angle. Or you take out this angle, you take out this angle. Both by using linear pair. And then sum of measures of three angles of a triangle is 180. So that way also can do. But if you use any one linear pair, and then if you use that sum of measures of two remote triangle equal to measure of exterior angle, then it will be two-step. And if you use the sum of measures of three angles of a triangle equal to 180 degree, then there will be three-step. So definitely, why to do by three-step? Where we are getting the answer by two-step? Because our main aim is that in exam how to minimize the time, how to save that time. So that is the main criteria. Okay. So let's see. Start with this one. Angle S P R plus angle Q P R equal to how much? 180 degree. What is the result? Result is linear pair. Linear pair. Then angle SPR is already there, 125 degree plus angle QPR equal to 180 degree. Then angle QPR equal to 45 degree. I skip one step. That step you write it down. Okay. Then QPR we got. Then sum of this angle plus this angle equal to measure of this exterior angle. So angle QPR plus what is given in the name in the book, angle PRQ. Angle PRQ equal to angle PQT. Now by what property? By the property of sum of measures of exterior angle and interior angle. Sum of measures of two remote interior angle equal to measure of exterior angle. Okay. So that property. You please write down within a bracket. Then you see Now angle QPR, what is that? 45 degree. So plus angle PRQ equal to how much? 110 degree. 110 degree. So equal to angle PRQ equal to how much? 55 degree. 55 or 65? 165. 65 degrees. Okay? So you got the measurement of angle PRQ. Now you can check. If we do this one, this one will get over. See. 65 degree plus 45 degree equal to 110 degree. Yes or not? Now this one will be how much? 70 degree. 70 plus 65. 70 plus 65 equal to 135. Your answer is correct. Okay? So my dear student, you can verify your answer by yourself. No need to go through your answer page. You can check by yourself. Okay? So then next question. Yeah, most of the diagram given, so your work became more easy. So next question, question number 2. Question number 2 you see. Figure number 6.40. X, Y, Z. And then Y, O, Z. Y, O, Z. Now what is given? This is 62 degree. This is 62 degree. This is 62 degree. And then other one how much? See, OZ, OI and OZ are angle bisector. Okay? Angle XYZ. XYZ is given 54. XYZ. As a whole, this is 54. This is 54. Now, see, one thing is see, X is given, Y is given. Can you get the Z, angle Z? Two angle given. We have to find out the third angle. By what? Using the angle sum property of a triangle. So write, first of all you write, by angle sum property of a triangle we get, by angle sum property of a triangle we get angle X plus angle XYZ plus angle XZY equal to 180 degree. If you are writing in the beginning, then bracket not needed. If you don't write in the beginning, then within the bracket you have to write angle sum property of a triangle. Then, what is that? 62 degree. Then this one 54 degree. Then this one is how much? X, Z, Y equal to 180 degree. Then ultimately how much? Ultimately angle X, Z, Y equal to. So see, 180 degree minus 116 degree. So ultimately how much? Angle X, Z, Y equal to 64 degree. Now you see, we got angle Y, we got angle Y, we got angle Z. And already given OY and OZ are bisector of angle Y and Z. Then what we have to do? See, since OY is bisector of angle XYZ, then angle XYO plus angle O, otherwise I write equal, so that, okay, because bisector, no, OYZ equal to 54 degree by 2 equal to 27 degree. So, because this OY is bisector, so this part and this part is equal, so 54 by 2 equal to 27 degree. Similarly, angle XZO equal to angle OZY equal to 64 degree by 2 equal to 32 degree. Now you see one thing. Once again we got this angle. We got this angle. We got this angle. We got this angle as well. So both these two angles we got, and we have to find out angle YOZ. We have to find out angle YOZ. So I drop this part. So please, my dear student, please you copy that one, but at the same time, please try to understand also. Then angle YOZ plus angle OYZ plus angle OZY equal to 180 degree. Angle sum property. YOZ how much? YOZ we have to get YOZ. Then OYZ equal to how much? 27 degree. And this one how much? 32 degree. So ultimately 180 degree. Ultimately I'll skip one step. That step you do by yourself. 121 degree. 121 degree. So this is the solution of question number 2. Then 3 you do by yourself. Question number 3 try to do by yourself. Now I'll proceed for question number 4. 4 also diagram is there already. 4 I'll proceed. So one thing is that you have to write and practice. Don't, if you go through only, then you cannot. So please write and practice. Now question number 4. 4 diagram already given. 6142. Question number 4. So see. This is the diagram given. PRT, S and Q. Then what is there? 95 degree, 40 degree. 95 degree according to my diagram it may not be. So you please draw nicely. Then 75 degree. Now what they are asking? They are asking find the angle SQT. SQT. So it is also, this one also almost same as previous one. Until and unless we take out angle STQ, we cannot get by angle sum property. But before that, you have to get this angle also. This angle also you have to get. So from triangle, so you can write from triangle PRT. What will you get? 95 degree plus 40 degree equal to plus angle PTR equal to 180 degree. So two angles we got, and you have to find out only angle PTR. So what you have to do, angle PTR equal to 180 degree minus 135 degree. So ultimately how much? Angle PTR equal to 45 degree. So we got angle PTR. The moment we will get angle PTR, we will get this angle as well. Why? What is the reason? Because vertically opposite angles. Vertically opposite angles. So you please write angle STQ equal to angle PTR. Within bracket you write vertically opposite angle BOA. Vertically opposite angles. Then angle STQ equal to 45 degree, because angle PTR equal to 45 degree, angle PSTQ also 45 degree. So once again, whatever we have done in this triangle also we have to do the same. So what it will be? From triangle SQT we get. So what it will be? 45 degree plus 75 degree plus angle SQT equal to 180 degree. So this one you do by yourself, and within the bracket you write by angle sum property of the triangle. By angle sum property of the triangle. Now, so this is the question number 4, and then I will go to question number 6. 5 also, once again it will be homework for you. So for now, question number 6, very very important question. Question number 6. Please practice that question nicely. Very very important. Okay? And also, whatever I left, please try to complete all these. Please try to complete all these. Question number 6. You please draw the diagram. See, what is that? PQR, TS. Okay, so this is the diagram, and what you have to prove, angle QTR is equal to half angle QPR. Okay, so my dear student, please, this is very very important question. Very very important question. First you try to understand that conception of what will be used in this, and then only you copy, not before that. Okay, because this is the last question for today. So what we will write? First of all, you write that we know that sum of measures of two remote interior angles equal to measure of exterior angles. We know that sum of measures of two remote interior angles equal to measure of exterior angle. Then what will happen? Angle QPR given, no? QPR. Angle QPR plus angle PQR equal to angle PRS. Then one thing you see, angle QPR plus twice angle TQR equal to twice angle TRS. I did not explain how we got, but it is given in the book itself that TQ is the angle bisector of angle Q, and TR is the angle bisector of angle PRS. So if it is bisector, that means this angle equal to this. That means ultimately this one, if you take any one part, then that part is 2 times of this part. is equal to angle PQR. So that's the reason we have written twice. Okay. Then you see angle QPR equal to 2 angle TRS minus angle TQR. This is equation number 1. This is equation number 1. Again, then from triangle TQR we get angle TQR equal to plus angle QTR equal to angle TRS. Now here what is the angle given? Angle QPR. So QPR is not here. Here angle TRS is there and TQR is there. So what we will do, we'll keep angle QTR equal to angle TRS minus angle TQR. This is equation number 2. Now, my dear student, one thing you see, TRS minus TQR equal to QTR. So from 1 and 2, what you will get? From 1 and 2, we get angle QPR equal to twice angle QTR. So ultimately implies angle QTR equal to half angle QTR. This is the answer, I believe. Angle QTR equal to half angle QPR, and this is the solution of this question. So once again, you see, this is the bisector, this is also bisector, that means TR is bisector, TQ is bisector, and 2 times we use 2 different triangles and we have solved the equation. So with this, I will wind up, but 2 questions are left. Question number 3 I did not do, and then question number 5 also I did not do. So these 2 questions you have to do by yourself, and you please send me in the next class, before next class. With this, thank you. Have a wonderful